Hi, my name is Taylor Scott, and today we'll be talking about the angular momentum of the solar system and its astronomical bodies, while specifically talking about how the conservation of angular momentum affects the Earth and Moon system. So, our solar system is made up of astronomical bodies that are gravitationally bound to the sun. The sun acts as a gravitational force that helps keep our planets in orbit. The planets that orbit around the sun are Mercury, Venus, the Earth and the Moon, Mars, Jupiter, Saturn, Uranus, Neptune, and the dwarf planet Pluto, while also other things such as other moons to other planets, um, asteroids, comets, and things like that. So, according to the nebular theory, our solar system was formed about 4.6 billion years ago by a giant molecular cloud of gas that began to rotate and collapsed that to form the sun and the protoplanetary disks. The cloud um, spun and was collapsing at the same time, which is also conservation of angular momentum, and its center formed the sun and the planets. So the inner and outer planets, our inner planets would be Mercury, Venus, Earth, and Mars. These are smaller and more dense planets, which are located about 1.5 astronomical units from the sun. They have shorter orbital periods because they are closer to the sun. And these planets carry a smaller fraction of angular momentum compared to larger planets such as Jupiter, Saturn, Uranus, and Neptune. These are gaseous planets that are larger and more distant. These planets are what mostly take up or mostly dominate the angular momentum because of their size and how large their orbits are. The moons and the smaller astronomical bodies, such as asteroids, comets, and dwarf planets, are all part of our system. The moons add a small amount of angular momentum to the solar system um, as they orbit around their planets. Asteroids and comets are basically remains of earlier solar systems that could have or have existed. And dwarf planets really don't have any addition to angular momentum compared to other planets such as Earth or Jupiter. So, angular momentum and gravity. Gravity plays a large and important role in our solar system structure. The sun's massive gravity is basically like a control panel for how the planets orbit, and the further away a planet is from the sun, the weaker, the closer it is, the stronger their gravitational pull is. And the sun has a large mass of about and holds a large mass of about 99.9% of the total mass of the solar system. And there and our planets have two main types of motion in the solar system. Orbital, which is the planets orbiting around the sun, and rotational, which is the planets spinning on their own axis. These orbital motions basically are creates a conserved quantity called angular motion, and all of these objects interact due to the gravity and angular motion, which basically keeps everything structured and in orbit to create from drifting or planets crashing into the sun. So angular momentum is the measurement of the quantity of rotation. So momentum is basically the rotational equivalent of linear momentum. And angular momentum is represented by L and includes these three things in its formula, which is M, mass, basically how heavy an object is; V, velocity, how fast the object may move; R, radius, which is the distance from the object from its center; like the center of the Earth or the center, or basically the sun in the solar system. And the complete formula for angular momentum is angular momentum equals mass times velocity times radius. And the equations for angular momentum using vector form is angular momentum times radius times linear momentum. And the scalar, which is the magnitude form, would be linear momentum times radius times mass times velocity, sine theta. And the formula for spinning objects like planets would be linear momentum times I times inertia omega, which, and the complete total formula for the system, for the planetary system, would be 3.3 times 10 to the 45th 10 to the 45 kilograms meters per second squared, or meter squared per second. And this basically means that these equations come up to be, basically means more mass and faster speed means more angular momentum. So the more mass you have, the faster it gets, which makes more angular momentum. And based on the angular momentum changes when the mass distribution changes. And so the distribution of angular momentum, the sun's large mass causes it to have less than 1% of the angular momentum. So that means that while the sun has a very large mass, the sun's radius compared to small orbital distances, the sun's radius is smaller compared to the orbital distances to other planets. And on the other hand, Jupiter is massive and has a faster speed and a larger distance, which creates up to 60% of the entire solar system's angular momentum. And so that means that even though the sun has almost all the mass, it holds almost none of the angular momentum, and most of the angular momentum is stored in the orbits of larger planets such as Jupiter. The conservation of angular momentum and Earth. So the law of conservation basically means that if no external torque acts on a system, the momentum remains constant. And if the inertia changes, the rotation speed would change. And a common example for this would be like if an ice skater pulls their arms in, they spin faster. If they pull their arms out, they spin slower. And basically, how the conservation of angular momentum relates to Earth would be Earth's rotation slows down every year and becomes longer by 1.7 milliseconds per century, and the moon moves further away from Earth about 3.8 centimeters a year. And the total angular momentum is conserved but shared differently between the Earth's spin and the moon's orbit. So the slowing of Earth's rotation and the moon drifting away is a direct result from angular momentum conservation. So to conclude my presentation today, the solar system is governed by gravity and angular momentum, and the angular momentum helps keep the planets steady in orbit, and giant planets such as Jupiter hold most of the angular momentum, especially Jupiter. Especially Jupiter. And the sun has almost most of the mass, but very little angular momentum. And the angular momentum is conserved, especially in the Earth, especially relating to the Earth Moon system. And so as a result, the Earth slows down and the moon drifts away. My AI reference sources that I use for this presentation today are ChatGPT, Gemini Google, and Copilot Microsoft. Thank you.